the Advancing Energy Podcast, featuring topics and trends on precision power conversion, measurement, and control solutions.
Hi everyone, my name is Dhaval Dayadkar. I'm the Vice President of Critical Sensing and Controls at Advanced Energy, and I'm at AE's Fort Collins location here, and with me is Dr. Jürgen Braun. It's my pleasure to introduce him. I've actually worked with Jürgen for about 15 years, so I'm really excited to have him talk about advancements in plasma power delivery. Welcome, Jürgen. Do you want to share a little bit about yourself?
Thanks, Dhaval. So my name is Jürgen Braun, and I'm the Senior Vice President of Plasma Power at Advanced Energy. Before holding that position, I was running the Thin Films group at Advanced Energy, and before that, the Photonics division with Advanced Energy. And then, even before, I have been dealing the European sales organization and leading the European sales organization for Advanced Energy. Before I joined Advanced Energy, however, I have been working for a company called Madsen Technologies, which is a semiconductor manufacturing equipment company. And I have been working in process development and product management with Madsen Technologies. My background is in physics and chemistry, and I have a PhD in surface physics and chemistry.
Thank you for sharing that. That's great. Let's get into our first question. Advanced Energy has been powering processes for about 40 years. What are some of the pivotal innovations or breakthroughs that Advanced Energy had in plasma process delivery?
AE has a really long history in industry-first technologies that enable advanced semiconductor manufacturing, right? So, for example, in the 90s, we have been introducing game-changing technology with our switch mode RF power supplies, and we have been pivoting the way of dielectric materials sputtering with our pulse DC technologies. Later then, in the 2000s, we have actually been transforming the industry with first of its class pulsed RF technology, and also with digitally controlled matchboxes that are used for matching power, and finally fast matching power into an RF plasma, which in today's processes is the number one key factor to produce devices that are used for semiconductor advanced nodes, and all the deposition and etch processes are run by these technologies.
Oh. Thank you for sharing that. Those are some really exciting innovations. And, we have been talking lately about the semiconductor industry entering the angstrom era, where the device features will now be measured in angstroms, or the diameter of an atom. So what kind of breakthroughs is Advanced Energy looking at to support entering the angstrom era?
That is a really interesting question, Dhaval. So when we're looking at our 45 years history of power delivery or power solutions delivery, we have really been pioneering and partnering with our customers to come always up with at the forefront technology that is needed for semiconductor manufacturing and advanced device node processing. So just recently, we have been working and launching a product platform that is called Everest into the market, which is really a game-changing and transforming technology again, as we have been done previously, where we are introducing multi-level pulsing capabilities, which is the first time that this is going to be used in the market for 2 nanometer and sub 2 nanometer technology node processing. And this comes with a modular hardware and firmware architecture, so we are able to have very fast controls, very modern control algorithms, and very modern adaptation to very unique customer problems in how to run a process and influence chemistry and kinetics of processes. So along with Everest, we have also been introducing a new digital platform for matching of these multi-level pulsing capabilities of RF generators, which is called the NavX. NavX is specifically designed to pull all the benefits out of an RF generator that comes with all these capabilities, so we can have best-in-class matching and fastest possible matching of processes on the wafer into the real geometries that are finally enabling to run these device nodes and generations. And then last but not least, we have also come up with a really game-changing technology that is supporting a new inflection point in the industry where bias technology is going through a significant change in how bias power is supplied to these processes. Instead of having a single frequency or dual frequency RF, we are now going with asymmetric pulsed DC, and with that we are able to tailor ion energy distribution to very monolithic ion energies, and we are able to transform very critical processes that we see in 3D device generation manufacturing, like gate-all-around processes or 3D memories, to be very precise, like using a scalpel instead of a broad brush to run processes.
Wow, that is really exciting. Seems like AE is really pushing the envelope with its state-of-the-art technologies. So, as you continue to push the envelope, what kind of challenges do you see with future developments or future trends in the market?
Yeah, as we are getting smaller and smaller in these device technologies, repeatability and accuracy is becoming a greater and more pronounced requirement. So finding new tricks and avenues and capabilities inside of power manufacturing and power tailoring and power delivery is going to be the key question that needs to be answered. Advanced Energy, again, is, I think, leading the path here in introducing new capabilities in how we are measure and control our power that is delivered into the plasma processes, so we can create these repeatabilities and accuracies that are needed for very advanced technologies.
So it seems like you're working on a lot of exciting innovations. So if you had to pick one or a few things that you're really excited about the future, which ones would you pick?
I think the most exciting is really to have all these capabilities synchronized and optimized in a fully functional system where all the elements of a system that control plasma, which is sensor technology, power delivery technology, and then also bias technology, are talking together and are creating a symphony based on what the chemistry, the kinetics of the process will need, and then are able to online control in real time to have the best possible results on the wafer.
Okay. And then personally, what excites you the most about the future of plasma power development?
I mean, it's an interesting industry that we are working in, right? And when we are looking at what is going to come in the next few years, it's even more exciting. The industry is growing. The industry is going to provide over and over new challenges that we have to solve. And I think here at Advanced Energy, with our good team, our engineers, our core capabilities that we have in our long history, we are well positioned to pave the path forward so we can provide our customers with new technologies. I think that's the most interesting and exciting attribute of what we are working on, is making things work that are really complicated.
Yeah. Great. Well, thank you, Jürgen, for your time. This was a very interesting conversation, and thank you for sharing your insights. And thank you, everyone. Please don't forget to like and subscribe our channel at Advanced Energy. Bye.
Right. Thanks.
Thank you for joining us for this episode of the Advancing Energy Podcast. Be sure to subscribe